Hi, and welcome to my channel. My name is Abolaji, and today we'll be coding multi-dex arbitrage bot. One of the new opportunities that the advent of blockchain has brought is profiting from arbitrage opportunities that occur on dexes on the blockchain. So, if you don't understand what I've just said, no problem. I'm going to break it down. Arbitrage are opportunities that exist because there are price differences across dexes on the blockchain. So we have exchanges on the blockchain and we call them decentralized exchange. A good example is Uniswap. We have Aerodrome and many other ones, Pancakeswap, alienbase. So for example, if can be going for 1,600 on Uniswap and at the same time is selling for 1,601 USDC on Aerodrome. So imagine you are able to buy ETH on Uniswap at 1,600 and sell it immediately on Aerodrome. You'd have just made 1 USDC. So, and imagine if you're also able to buy as much as 10, 20 ETH, and in that case, you would have made 20 USDC. And you can do this as many times as possible as long as this arbitrage opportunity exists on chain. So the good thing about this opportunity is you also don't have to have this much money. In fact, you don't have to use your money to take advantage of this opportunity. Now, there's a protocol called Aave, and there are many other protocols too that gives you flash loan. Flash loan are just normal loans, and in this case, you don't have to put down a collateral. um, you can borrow as much as you want, provided that you are able to repay this flash loan within the same transaction, within the same block. So we'll be testing our smart contracts on Base blockchain. So in the case of Base blockchain, one block time is about 2 seconds. So you have to repay the flash loan within 2 seconds with a fee of 0.05%. Now, again, that's quite short, but you can do a whole lot on the blockchain with that um, flash loan and make something from it. And one of the things you can do with this flash loan is this arbitrage bot. And today, that's what we are going to be doing. Our bots will be able to take flash loan from Aave V3, and it will take assets like USDC or worth. That's what we are going to be borrowing, and it will also have the capability to swap on these 5 different decentralized exchanges, namely Uniswap V3, Aerodrome V2, Pancakeswap V3, Sushiswap V3, and alienbase. Then after the swap, it's going to repay the flash loan on Aave V3 with 0.05% fee. Then it will check if the arbitrage if our transaction was actually profitable. If it's profitable, it will send the profit back to us. Otherwise, the whole process will be reverted. And in that case, we would have just lost the gas fees we have paid so far. On Base blockchain, the gas fee is less than 1 cent. So that's the risk we'll be taking. We'll probably lose 1 cent if this fails. So let's jump to the IDE and start coding. All right. So here is my IDE. You can use any IDE you're comfortable with to follow me. Just ensure that you have Foundry already installed. To check whether your installation it's okay, just run Forge version with me, and you're supposed to get. Okay. Let me correct that. It should be dash dash version, and you're supposed to get this response. All right. So if you're struggling with that, I'm going to leave a link to the Foundry documentation for you to be able to set up Foundry on your IDE. All right. So we have that. Then let's create a folder for our project. I'm going to create a folder now, and I'm going to name it Multi-dex bots. All right. The folder is there. So let's cd into our folder. All right, that's good. Now we can now initialize our project by running forge init dash dash no commits. All right, so that we don't push immediately to the GitHub. Now that we have that, we can check our project and we can see the list of folders already there. This is the source folder. This is where our contract is going to be. This is where our test file test would be. That's the unit test. We'll not be writing unit test, but we'll be testing on a forked live forked base mainnet. All right, so let's start with our contract file. I'm going to create that in the source folder, and I'm going to name it multi-dex bots.so. That's how to name your contract in Solidity. So over here, this placeholder file, I'm going to delete it. We don't need it. All right, we have our blank file. The next thing is to define our Solidity version. So we'll be using the open source MIT license, and we'll be using a recent Solidity version. Anything greater than 0.0, 0.8, and that's what we'll be using. The next thing is with contracts keyword, we are going to define our contract, and it should be exactly the same name with the file. So I'm just going to copy this. Yeah, and inside here, that's where the code of our contract will be. All right, so quick recap of what our code is going to do. As we've said, we want to be able to get flash loan from Aave V3 and repay the flash loan with fee or premium, because that's how the protocol makes money. Then the next thing is we want to also be able to swap we want to get the flash loan from Aave V3. So we need to specify assets. The loan will be in a certain asset, either USDC or WET. That's the asset we are going to be borrowing. WET is wrapped if. So those are the two assets we'll be interested in borrowing. Then we'll also be able to swap the borrowed assets, swap the borrowed assets on specified dexes, including specified dexes. The supported dexes are Uniswap V3, Aerodrome V2, alienbase, we have Sushiswap V3, and we have Pancakeswap. So these are the dexes we are going to be supporting. So with this, now we know what to focus on. So the next step is to implement how to interact with Aave V3. According to Aave documentation, these are all the Aave contracts and interfaces would have to call in our contract. So I'm going to leave the link to Aave's documentation in the description of this video. So these are the things we're going to need. This last one is just going to be for us to debug our contract. Forge console. It will allow us to console log some parameters when we are debugging. You would see how useful it is. But to inherit this contract in our bots, we have to define it this way. So multi-dex bot is flashloan simple base. So after this, would have to install all of these Aave contracts. Now, if we try to compile these contracts, it is not going to compile. Let's do that. Run forge build, and you can see the error. So everything we have imported, all these Aave contracts, they are not installed. That's why we are getting this error. So let me just clear my terminal and let's try and install the Aave contracts. So you're just going to run forge install at Aave DAO at Aave V3 origin. Still going. Alright, you can see they are still being installed, and you can see the error. It's disappearing. I'm just waiting for this to finish the installation. Yeah, it's okay. Right, our installation has been completed. You can see they are no longer underlined. The imported contracts are here now. If you check library and you see the new folder Aave V3 origin, you see all the contracts there. Yeah, so there's still one more imported interface that is still not here. This is our ERC20 interface, and this will be useful for us to work with ERC20 tokens. So this is imported from OpenZeppelin contract, so we need to install that too. We will run forge install OpenZeppelin at contracts. So let's run that. Okay, we just got error, and it's because I'm supposed to do dash no commit, but I did dash no commit. So let's run it again. It should be fine now. Yeah, I was getting error with installation of OpenZeppelin before, but I hope I have resolved it now and it's working well. So this is actually the correct command for install OpenZeppelin /OpenZeppelin contracts dash no commit. So it's running now. We just need to wait a couple of seconds for it to be done. Right, it seems we are ready. Yeah, the installation is complete now. So at this point, we need to, let me hide the terminal. You can always hide your terminal by using, if you're on Mac, you use Command J. I'm not sure of that on Windows, but I think Control J should do that. Please confirm. All right, so we have this. The next thing is one of the contracts we are importing, flashloan simple base, as a constructor. So, alright, to make it look better, I've just created and included my PTR file here, and also increased my code width here, the print width, so it makes my code looks better. I like it this way. All right, so we have the constructor. Now let's create the first function we're going to be working with, and this is start arbitrage function. Let me just remove this modifier. So here's the function, the start arbitrage. This is the function we are going to be calling to start the arbitrage, and our contract is going to call this pool contract on Aave, call the flash loan, and get the specified assets. So the specified assets, as we said, would be either USDC or WETH. Then we state the amount we want. Then it gets the flash loan this way. All right. Now we want to ensure that we are the only one that can call this function. So to do that, I'm going to create a state variable here, address public immutable, and it's going to be owner address, the owner of this contract, and this is where the constructor is going to be very useful. So whoever deploys this contract becomes the owner of this contract. So this is msg.sender, runs once. So the owner address, we have the owner address now. So we want to ensure that we limit those that can call this start arbitrage function. So I'm going to create a modifier. We are going to call it only owner. Now it's going to check wherever we put this modifier, it's going to check if whoever is calling the function is the owner. If it is not the owner, it's going to revert with this error, not allowed. But if it's the owner, then the code will run. So I'm going to define this error up here. Hope I'm correct. Yes, it should be somewhere up here. Yes, not allowed error. So with this modifier we've created, we are going to use it to restrict this function. Now, according to Aave documentation, we also need to implement another function called execute operation. Now, execute operation is the function that gets called by the pool contracts, Aave pool contracts. So when we call Aave pool contract here and tell it that we want to borrow an asset of this amount, and it should send our loan to this contract, to this address called address this, Aave contract takes every of our parameter and calls back into our contract this execute operation with all these parameters. So that's what I've implemented here. Now we need to ensure that it is Aave pool contract that is calling this function, and it's not a random contract. That's why we are testing if the msg.sender, whoever is calling this contract, is not pool Aave pool, then it should revert with this error. So let me implement this error. I usually prefer to use if statement for my error. I prefer it to require, because require, you would be storing strings on the contract on the blockchain, and that actually costs more. So that is done. Now here is the data parameter we encoded here. I have not explained that, and this is one of the most important parts of this contract. Now this data here parameter allows us to encode any command, any code we want here, and it's included in the parameters we use to call the pool contract on Aave. Then this byte data is returned to us as params, and we can now decode. Now when we decode, after we decode, we can now perform any arbitrage arbitrage swaps here. After we do that, then we can now check our debt. Now this premium is the fee we are going to pay on the debt we have borrowed. So that's our total debt. So we need to approve the pool contract, Aave pool contract, to be able to take this money, these assets back from us. Otherwise, the loan would not be issued to us in the first place. So we need to do this. Then after that, we'll check whether the swap, the arbitrage swaps we did here was profitable. So when it's profitable, yes, we are supposed to write a code to send the profit to us. We'll still get there. So we are emitting an event here to show that everything went well. So I need to define this event. So I'm going to come here now, and over here I'm going to define this arbitrage executed event. So this should be unit 256 and unit 256. Functionality I would want us to include is this withdraw function. It's going to prove very important when we start implementing our arbitrage swap, because when you're swapping from one token to another, some tokens will be stuck in the contract, and we should be able to withdraw it out. So with this withdraw function, you can see it's limited with this modifier. Only the owner of this contract can call it. So you'll specify the token address you want to withdraw from the contract. Then this internal function send token transfers it to us. It transfers it, yes, to the specified address. In this case, it's going to be the owner. So yeah, it's going to be quite important when we are doing swap. Now to ensure that other people can use your contracts, you just need to, once they are authenticated or whitelisted, or if you have multiple wallet addresses and you want to use another wallet to start the arbitrage. So we are going to create a mapping for that. Our mapping take address and return bool to us. I want it to be a private variable, and it's going to be called is white listed. Alright, so what is white listed mapping is going to do for us is that it's going to be working with this two it's going to be working with these functions, these two functions, whitelisted address. So with this whitelist address, we, the owner of this contract, can add another address and set it to true, or we can remove an existing address and set it to true. Right, so what this will allow us to do is to create another modifier. We're going to create another modifier here the modifiers are, and the name of the modifier will be only whitelisted. So only whitelisted will check if the calling address is a whitelisted address and allow you to run the code if it is whitelisted. If it is not whitelisted, it's going to revert. So instead of us being the only one to start arbitrage, then multiple addresses, other addresses that we have whitelisted, can also start the arbitrage. So interesting. So let's see how far we've gone and see if our contract is still compiling. Hopefully it's still compiling. Okay, we have a couple of mistakes here. Yeah, this is meant to be a semicolon. Okay, unauthorized. We've not defined this error, so let me define it here. So once we define the unauthorized error, he'll compile the contract again. Everything just works well. So let me compile the contract again by running forge build. You can see no files changed, compilation skip, so everything is okay now. So at this point, please, if you're enjoying this video, please do not forget to like this video and subscribe. It helps me to create more content like this. Now the